Imagine walking into a room where the lights are still warm and the chairs are pushed back, and slowly realizing the party ended long before you arrived. Tonight, I want you to picture the whole galaxy that way. For 75 years, we have asked where everybody is, and assumed the silence meant the room was empty. But what if it was once crowded? What if 1,000 civilizations rose, wondered, and went dark before our sun was even born, and the quiet we hear is not a beginning, but an aftermath? We are going to follow that idea gently, all the way down to the single number it hinges on. So get comfortable, settle in, and subscribe if you'd like to come along. We arrived late, and the house is very quiet. Part 1. The wrong question. There is a question that has haunted science for 75 years, and almost everyone who asks it the wrong way around. In 1950, over lunch with a few other physicists, Enrico Fermi is supposed to have paused mid-conversation and asked, almost offhandedly, "Where is everybody? The galaxy is old. The galaxy is enormous. The stars are uncountable. So if anyone else is out there, why has no one ever called, knocked, or left so much as a footprint we can find?" For 3/4 of a century, we have turned that question over, and we have nearly always assumed it means the same thing. We have assumed it is asking why the room is empty. Tonight I want to ask it the other way. Not where is everybody, but what if everybody already came and went? What if the silence we hear when we point our instruments at the dark is not the silence of a room before the party, but the silence of a room after it? The chairs pushed back, the lights still warm, the guests long gone. What if we did not arrive too early to a galaxy that is not yet filled? What if we arrived far too late into a galaxy that was once crowded and is now a graveyard? I want you to sit with that image for a moment, because it changes the feeling of the whole sky. When you look up and imagine an empty universe, there is a kind of loneliness to it, but also a kind of innocence. Nothing has happened yet. The story has not started. But when you look up and imagine a universe that was full and is now quiet, the loneliness becomes something else. It becomes the quiet of a place where everything already happened, and you missed it, and no one left a note. That is the possibility we are going to follow tonight, slowly, the way you would follow a single thread through a dark house to see where it leads. And here is the strange thing, the thing I find I cannot stop thinking about. The entire question, this whole enormous mystery of whether the galaxy is full of the living, the dead, or no one at all, comes down in the end to a single number, not a telescope, not a discovery. A number, one quiet little value that we do not know and have never known and may not learn for a very long time. We are going to circle that number all night, and each time we come back to it, it will mean a little more. For now, I will only tell you that it measures something achingly simple. It measures how long things last. I should tell you what kind of journey this is going to be, because it is not a frightening one, even though the idea at the center of it sounds frightening. This is not a horror story. This is the kind of conversation you have late at night with someone you trust, when the lights are low and there is no hurry, and you find yourselves talking about something enormous, not because it scares you, but because it is genuinely one of the most interesting things a person can wonder about. We are going to take our time. We are going to build the idea one careful piece at a time, the way you build anything real, and the drama, when it comes, is going to come not from me raising my voice, but from the facts simply stacking up until they lean against you. There is a reason this particular framing has stayed with me, and it is the way it changes the meaning of our loneliness. We are used to thinking of the search for other civilizations as a search for company, for someone to talk to, for the comfort of knowing we are not alone. But the graveyard idea asks a harder and stranger question. It asks not whether we have neighbors, but whether we have ancestors we never met, predecessors who walked this same road of curiosity and ambition and fell silent before we were born. It reframes the night sky from a waiting room into a kind of inheritance, a place haunted not by aliens we might meet, but by civilizations we just missed, separated from us by the one gap that cannot be crossed, which is time. And if that is true, then every time we look up, we are not scanning for visitors. We are visiting a cemetery so enormous that we cannot read a single name on it, and have not even realized, until now, that it is a cemetery at all. If you have wondered about the Fermi paradox before, you have probably heard the usual answers. Maybe life is rare. Maybe they are hiding. Maybe they are too far away. We are going to touch all of those and give each one its fair hearing, because they deserve it. But the angle I want to take you down tonight is one that often gets mentioned and then hurried past, because it is the one that makes people uncomfortable. It is the possibility that the galaxy is not quiet because life is rare, but because civilizations do not last. That the night sky is not an empty page, but a cemetery so old and so enormous that we cannot even read the headstones. There is one more thing I will promise you now, and then ask you to hold on to until the very end. As dark as this idea sounds, there is a reversal waiting for us, right at the close, that turns the whole graveyard on its head. It is a real idea, taken seriously by real scientists, and it suggests that what looks like a field of the dead might be something far gentler and far stranger. I am not going to spoil it yet. I only want you to know it is there, waiting, like a light left on in a far room, so that as we walk through the darker parts of this story, you will know we are walking towards something, and not just into the cold. But before we can call this silence a graveyard, we have to earn the word. We have to ask the obvious question first, the one that makes the whole thing a paradox in the first place. Why did we ever expect to hear anything at all? Why should the galaxy be crowded? Because if there was never any reason to expect company, then the silence means nothing, and there is no mystery here, only an empty house that was always empty. So that is where we begin, not with the silence, with the noise we expected and never got. Is less than break time equals 1s, is greater than number, part 2, why the galaxy should be crowded. The reason Fermi's question is a paradox, and not just an idle wondering, is that the numbers really do seem to promise a crowd. To feel why the silence is so strange, you first have to feel how loud the galaxy should be, and to do that we have to start with time, because time is the part our intuition gets most wrong. Consider how old all of this is. The disk of our galaxy, the great flattened wheel of stars we live inside, is something like 13 billion years old. Our own world, the Earth, is about 4.5 billion years old. Take a moment with those two numbers side by side, because the gap between them is the whole story. The galaxy was already more than 8 billion years old, more than half, again the present age of the Earth, before our planet even formed out of dust and rubble around a young sun. That means there were billions of years, an almost unthinkable run of time during which other worlds could have formed, cooled, grown life, grown minds, built civilizations, and done all of it before the ground you are standing on had finished cooling. Let me try to make that gap into something you can hold. Imagine compressing the entire history of the galaxy into a single 24-hour day. The galaxy forms at midnight. On that scale, the Earth does not form until the early evening, somewhere around 6 o'clock. The first simple life on Earth shows up a little later. Complex creatures, the kind you could see with your eyes, do not appear until the last hour, and all of human history, every empire, every song, every word ever written, every face that has ever looked up at the stars and wondered, all of it fits into the final fraction of the final second before midnight. We are not the early risers in this galaxy. We are the latest of latecomers, stumbling in at the very last tick of the clock. And the question that should make the hair on your arms stand up is simple. In all those hours before we arrived, who else was awake? Now add the second ingredient, which is worlds. For most of human history, we did not know whether other stars had planets at all. We hoped. We assumed. But we did not know. That changed in our own lifetimes. With the Kepler Space Telescope and the missions that followed, we went from guessing to counting. And what we found was that planets are not rare at all. They are ordinary. They are nearly everywhere. The current understanding is that a large fraction of stars, including stars much like our Sun and the smaller, more common red dwarfs, host a roughly Earth-sized world somewhere in the temperate zone, the region where a planet is neither scorched nor frozen and liquid water could pool on its surface. Put a number on it, and the number becomes hard to believe. Our galaxy holds somewhere between 100 billion and 400 billion stars. If even a modest slice of those stars carry a temperate, roughly Earth-sized planet, you are left with billions of worlds where, as far as we understand the rules, life had at least a fighting chance to begin. Billions. Not a handful of lucky exceptions. Billions of rolls of the dice, spread across 13 billion years. When you say it out loud, the silence starts to feel less like the natural state of things and more like a puzzle that demands an answer. And then there is the third ingredient, and it is the one that truly turns expectation into paradox, because it removes the last comfortable excuse. You might think, well, even if there were thousands of civilizations, the distances are so enormous that they could never cross them, so of course we have not met anyone. But here is the trouble with that comfort. A civilization does not need to send living travelers across the galaxy to fill it. It only needs to send machines. Think about a probe that, on arriving at a new star system, uses the raw material it finds there, the asteroids and moons and floating rubble, to build copies of itself, and then sends those copies onward to the next stars. Each new system becomes a factory for the next wave. This is the idea of a self-replicating probe, sometimes called a von Neumann probe, after the mathematician who worked out the logic of machines that can copy themselves. You do not need many to start. You need one civilization, one time, to launch the first wave, and then the wave does the rest, doubling and spreading outward like a slow tide. When you do the arithmetic on that tide, the result is staggering, and it is the crux of the entire paradox. Even creeping along at speeds far below the speed of light, speeds we can already imagine with technology that does not break any laws of physics, a single civilization's probes could spread to every star in the galaxy in something like 1 million to 10 million years. Hold that number against the age of the galaxy. The galaxy has been around for 13 billion years. Colonizing it from end to end takes, at most, around 10 million. That means the time it would take to fill the entire galaxy is less than 1,000th of the time the galaxy has existed. The galaxy has had time to be crossed and settled, not once, but something like 1,000 times over. I want to slow down on how patient this process is allowed to be, because the patience is the point. We instinctively object that the distances are too enormous, that no one would bother, that it would take too long. But none of that matters when you have the whole timeline to work with. The probes do not need to be fast. They do not need to be in a hurry. They do not even need anyone back home to be alive and waiting. Once the first wave is launched, the wave itself does the spreading, building new copies from whatever raw material it finds and sending them onward, generation after generation of machines, long after the civilization that started it has gone. A single decision, made once, by a single culture, anywhere in 13 billion years, would be enough to leave fingerprints in every corner of the galaxy, including our own backyard. That is why the silence is so loud. It is not that we expected a crowd to come find us. It is that even one quiet, methodical, long-dead civilization should have left its machines drifting through our solar system already. And there is a detail about the stars themselves that makes the head start even more generous than I have let on. The most common stars in the galaxy are not bright suns like ours, which live for about 10 billion years and then die. They are small, dim red stars that burn slowly and last not for billions, but for tens and even hundreds of billions of years, far longer than the universe has so far existed. Those modest little stars are the marathon runners of the cosmos, and they are everywhere, outnumbering stars like our sun many times over. If life can take hold around them, and we genuinely do not know whether it can, then the galaxy has been quietly stocked with stable, long-burning furnaces for almost its entire history, each one a possible cradle, each one with billions of years to work with. The opportunities for life were not just plentiful, they were ancient and durable, and waiting long before we showed up. So here is where the expectation lands, and I want you to feel the full weight of it before we let it go. The galaxy is ancient, far older than us, with billions of years of head start. It is generous with worlds, scattering billions of temperate planets through its arms. And it is, in principle, easy to cross, given even a fraction of the time available. Every arrow points the same direction. The galaxy should be full. It should be loud. It should be so thoroughly settled that no matter where we pointed our instruments, we would stumble over someone's fingerprints. If you planted a single seed in a forest 13 billion years ago and came back today, you would expect, at the very least, to find the forest changed. And yet, when we finally built the instruments to listen and turn them toward all those promising worlds, across all that promising time, what came back was not a chorus. It was not even a whisper. It was nothing. And that nothing, set against everything we just built up, is so loud it has a name. So, now that we have heard how loud the galaxy should be, we have to go and listen to how quiet it actually is. Is less than break time equals 1s is greater than number, part 3, the great silence. We have been listening in a serious and organized way for more than 60 years. It is worth pausing on that, because people often imagine the search for other civilizations as something casual, a few dreamers pointing dishes at the sky on a hopeful evening. It is not. It has been a patient, methodical effort carried out by careful scientists with some of the best instruments humanity has ever built, and the name for what they have found, taken all together, is the Great Silence. The search began in earnest in 1960 when an astronomer named Frank Drake pointed a radio telescope at two nearby suns, like stars, and listened for any signal that looked deliberate, any pattern that nature does not make on its own. He heard nothing unusual, but he had started something. In the decades since, the effort grew into what we broadly call the search for extraterrestrial intelligence, and it has swept across thousands of stars, scanning enormous ranges of radio frequencies, looking for the one thing that would change everything, a signal that could only have been made by a mind. There has been, in all that time, exactly one moment that came close enough to break your composure. In 1977, a radio telescope in Ohio recorded a burst of signal so strong and so unexpected that the astronomer reviewing the printout circled it and wrote a single word in the margin: wow. The signal lasted 72 seconds, sat right where you might expect a deliberate broadcast to sit, and then it was gone. It never came back. People have spent decades trying to explain it or recover it, and despite every effort, the so-called wow signal remains a single, lonely question mark. Not a confirmed message. Not a hello. Just one strange knock on the door that, when we opened it, revealed no one standing there. It is the archetype of the whole search, a hope that flared and faded and left us exactly where we started. In more recent years, the search has grown far beyond radio. We have realized that a civilization might give itself away in many ways without ever meaning to. It might leak waste heat, the unavoidable warmth that any large-scale machinery throws off, detectable as a strange infrared glow. It might pulse lasers across the dark, It might build something enormous around its star, a structure so large it dims the starlight in a telltale rhythm. It might even change the chemistry of its planet's air in ways that no natural process would. We have looked for all of these. We have searched for the heat of hypothetical engines and the shadows of hypothetical megastructures. And the result, every time, has been the same. Nothing that we cannot explain by ordinary nature doing ordinary things. The freshest and most human example of how hard this is comes from our search not for civilizations, but for life itself, even simple life. And it is worth telling because it shows you exactly how thin the edge of our knowledge really is. There is a world about 124 light-years away called K2 18b, a planet larger than Earth and smaller than Neptune, the kind of world we think might be wrapped in a global ocean under a thick sky. Using the James Webb Space Telescope, astronomers reported a faint hint of a molecule called dimethyl sulfide in that planet's air. On Earth, that molecule is made mostly by living things, by ocean plankton, and so the hint set off a wave of excitement. Was this, at last, the chemical breath of alien life? But watch what happened next, because this is the real lesson. Other scientists looked hard at the data and pushed back. The signal was faint, far from certain, the kind of result that could melt away with more observation. Some pointed out that the same molecule has been found in lifeless places, in the icy material of comets, made by no biology at all. By the time the dust settled, the honest summary was that we had a tantalizing maybe and not much more. And here is the part I want you to hold on to. This was our single best whisper of life, anywhere beyond Earth, the closest we have ever come, and even it is contested, argued over, and quite possibly nothing. If that is how uncertain we are about the faint chemical sign of pond scum on a single nearby world, imagine how much fainter the trace of a civilization would be, especially one that died long ago. So we are left with the great silence, and I want to be careful and fair about what it actually means, because this is the hinge the whole night turns on. The silence is not proof of failure. It is not a sign that we have looked badly. In fact, you could argue we have barely begun. We have listened to a small slice of the sky, on a limited set of frequencies, for a sliver of time. Think of it this way. We have been able to listen with radio for only about 125 years, and seriously for only about 60. Against a galaxy that is 13 billion years old, that listening window is almost nothing at all, like dipping a single cup into an ocean, and concluding the ocean holds no fish. And yet, and this is the tension we cannot escape, even with that tiny window, we should have caught the loud ones. Remember the probes, the self-replicating tide that could fill the galaxy in a few million years. If even one civilization in all of cosmic history had launched that tide, the evidence should be everywhere. In our own solar system, around the nearest stars, impossible to miss, no matter how briefly we looked. The silence is not just an absence of faint signals from far away. It is an absence of the obvious, the unmissable, the galaxy-spanning. That is what makes it the great silence, and not just a quiet evening. It helps to picture the sheer size of the haystack we are searching for a needle that may not exist, and may never have existed, or may have rusted away long ago. The galaxy holds hundreds of billions of stars. A signal could arrive on any one of millions of radio frequencies, or as a pulse of light, or as a faint chemical trace in an atmosphere we can barely measure across light years. It could come at any moment, last for seconds, and never repeat the way the WOW signal did. To have a real chance of catching a deliberate broadcast, you would need to be pointed at the right star, tuned to the right frequency, at the right instant, with an instrument sensitive enough to hear it over the background roar of the universe. When you lay it out that way, the wonder is not that we have heard nothing. The wonder is that we ever expected to hear anything at all in the few decades we have been trying, having sampled a portion of the sky so small it would be generous to call it a thimble dipped into an ocean. And yet, I keep coming back to the loud ones, because they are the part that refuses to be explained away by the size of the haystack. A faint, deliberate radio message from a careful civilization, yes, that could easily slip past us. But a civilization that launched the self-replicating tide, that filled the galaxy with its machines over a few million years, would not be a needle in a haystack. It would be the haystack. It would be here, in our solar system, around the nearest stars, impossible to miss. The fact that we look around our own cosmic neighborhood and find it untouched, with no probes, no structures, no evidence that anyone has ever passed through, is the part of the silence that the haystack cannot excuse. Someone, in 13 billion years, should have been loud, and no one was. This is the fork in the road, and everything we do for the rest of tonight lives on one side of it. The silence has exactly two honest readings. The first is that the galaxy is quiet because it was always empty, because life or intelligence is so rare that we may be the only ones, or nearly so. The second is that the galaxy is quiet because it emptied out, because it was once full of civilizations that rose and fell, and we are walking through the silence they left behind. I am going to spend most of tonight inside that second reading, the graveyard, because it is the one the title promises and the one I find most haunting. But I give you my word we will come back and give the first reading its full and fair hearing before the night is over. Because if the galaxy did empty out, if the silence really is the quiet after the party, then everything, every single thing, depends on that one number I told you about at the very beginning. The number that measures how long things last. We have circled it twice now. It is time to walk straight up to it and look it in the face. Is less than break time equals 1s is greater than number part 4, a field of brief sparks. In 1961, the same Frank Drake, who had pointed his telescope at those first two stars, sat down to organize the question, and what he produced has been quietly running underneath everything we have said tonight. It is usually called the Drake equation, and the word equation makes it sound colder and more certain than it is. It is not really a formula that spits out an answer. It is better to think of it as a way of breaking one impossible question into a chain of smaller, more honest ones. The chain goes something like this. How many stars are there? Of those, how many have planets? Of those planets, how many could support life? Of those, how many actually grow life? Of those living worlds, how many produce intelligence? Of those minds, how many build something that broadcasts its presence across space? And then, at the very end of the chain, the final link, the one I have been promising you all night. Once a civilization becomes able to announce itself to the galaxy, how long does it last before it goes quiet again? That last term, the lifespan of a communicating civilization, is the number. Scientists usually just call it L. Now, here is the thing that took people a while to fully appreciate, and it is the reason this whole video exists. You can be as generous as you like with every other term in that chain, and L can still swallow the answer whole. Suppose stars are plentiful, which they are. Suppose planets are common, which they are. Suppose life gets started fairly easily, and even suppose intelligence is not a fluke. Pile up all the optimism you want at the front of the chain. Fill the galaxy with billions of worlds and millions of budding civilizations. It does not matter, because if L is small, if civilizations last only a little while before they fall silent, then at any given moment, the moment we happen to be alive and listening, almost none of them are talking. The galaxy can have produced 1 million civilizations across its history and still be, right now, almost completely empty of voices. Let me give you the image that finally made this click for me. because the math alone does not land until you can see it. Imagine an enormous stadium, dark, the size of a continent, and imagine that over the course of 100 years, a great many people walk through that stadium, each one carrying a single match. Each person strikes their match, and it burns for a single instant, and then it goes out, and they move on. Over a century, thousands of matches are struck. The stadium has hosted an enormous amount of light in total. But now imagine you are standing in that stadium at one random instant, one single second out of the century, and you look around. How many lit matches do you see? Almost certainly none. Maybe, if you are very lucky, one flickering far away, too distant to reach. The stadium is not empty of fire. It is just that the fires almost never burn at the same time in sight of one another. That stadium is the galaxy, and the matches are civilizations, and the length of time each match burns is L. And when you frame it that way, you realize that the sentence "the galaxy is full of dead civilizations" is not some wild, frightening claim. It is simply what you get when L is small. It is the most natural reading of a galaxy where minds appear, shine briefly, and go dark. The dead are not an exception. The dead are the overwhelming majority. The living are the rare, lonely flickers, separated from each other by gulfs of space, and, even worse, by gulfs of time. Contrast that with the other possibility, just so you can feel the difference. Suppose L is enormous. Suppose that once a civilization learns to broadcast and to survive itself, it tends to last not for centuries, but for millions of years, settling in, spreading out, enduring. In that galaxy, the matches do not flicker and die. They become bonfires that burn for ages, and they overlap, and the stadium is bright with steady lights that have been shining since before our sun was born. In that galaxy, the silence makes no sense at all, because someone should still be here, glowing. The whole question, the entire mystery of the empty sky, comes down to which of those two stadiums we are standing in. The one full of brief sparks, or the one full of long fires, and we do not know. That is the maddening, beautiful truth at the center of this. We have no idea what L is, because we have exactly one example of a communicating civilization to study, and it is us, and we have only been at it for about 100 years, and we do not yet know how our own story ends. We are a single match, recently struck, and we cannot see whether we are about to flare into a bonfire that lasts an age or gutter out like all the rest. We are trying to estimate how long civilizations last by looking at the one civilization we know at the very moment it has just begun, before the burning is done. I find something almost vertiginous in that. The grandest question we can ask, whether the universe is full of minds or nearly empty of them, does not hinge on some distant galaxy or some exotic particle. It hinges on a number we could only truly learn by living it out, by becoming old as a civilization and looking back. We are not just the ones asking the question. We are, in a sense, part of the experiment that would answer it. Our own L is being written right now by us in real time, and we will not know the figure until it is far too late to change it. It is worth lingering on just how much weight rests on this single term, because when Drake and his colleagues first wrote down their chain of factors, the early terms were almost complete unknowns. We did not know how many stars had planets. We did not know how many planets could hold water. Today, remarkably, we have begun to fill those numbers in with real measurements, and most of them have come back encouraging, even generous. Planets are common. Temperate worlds are common. The front of the equation, the part about cosmic real estate, looks friendlier every year, which means the uncertainty has not gone away. It has migrated. It is piled up, more and more, onto the last terms, the ones about life and mind and survival, and especially onto L. We have spent 60 years narrowing the easy questions, and discovering that the whole mystery was always hiding in the hardest one, the one about how long the lights stay on. And here is a subtlety that makes L even more powerful than it first appears. It does not only set how many civilizations are talking at any one moment, it also sets whether they ever overlap enough to build on one another, to hear an answer in their own lifetime, to feel anything other than alone. A galaxy of civilizations that each last a few centuries is not just a quieter version of a galaxy of civilizations that last 1,000,000 years. It is a fundamentally lonelier kind of place, a place where being heard is almost impossible by construction, where every mind that ever wonders about the others is, in practice, wondering by itself. The number does not just count the living. It decides whether connection is even geometrically possible, and that is a heavy thing for one little unknown variable to carry. Let me make the timescale personal one more time, because it sharpens the blade. Human beings have been broadcasting radio into space for roughly 125 years. If the typical civilization lasts only something like that, only a few centuries of being loud before it falls silent for whatever reason, then the galaxy is not a stadium of bonfires at all. It is a strobe in the dark, countless brief flickers scattered across 13 billion years, almost never two at once, almost never close enough to see each other, even if they were. A galaxy full of life, and full of the dead, and empty of company all at the same time. But suppose the matches did, once in a great while, overlap. Suppose two civilizations did burn at the same moment, separated by only a few thousand light years. You might think, surely then we would see each other. And here is where the graveyard gets stranger and lonelier than even the matches suggest. Because it turns out that even if a dead civilization were burning right now, right next door in cosmic terms, there is a very good chance we would still see absolutely nothing at all. And the reason why is the next thing I want to show you. Is less than break time equals 1s is greater than number, part 5, why we would see nothing. Here is a fact that should change how you feel about the silence. And it is one of those facts that sounds obvious the moment you hear it, but somehow never gets said. A dead civilization is almost perfectly invisible. Not hard to find, not faint, invisible. Across the distances between stars, and across the spans of time we are talking about, a civilization that has fallen silent leaves behind almost nothing that we could ever detect, which means that even a galaxy stuffed with the remains of the dead would look, from where we sit, exactly like an empty one. Let me start with the most obvious thing a civilization makes, the thing we ourselves have been making for over a century: radio. We tend to imagine our broadcasts spreading out into the galaxy like ripples on a pond, a growing bubble of I Love Lucy and news reports announcing us to the stars. It is a lovely image, and it is almost entirely wrong. Radio signals do not travel forever as crisp messages. They spread out, and as they spread, they grow weaker, fading according to a brutal rule, dropping off with the square of the distance. Our ordinary broadcasts, the everyday hum of a planet's communications, sink below the background noise of the universe within just a few light years. They do not reach the next star in any readable form. They dissolve into the static of space almost as soon as they leave the neighborhood. Now think about what that means for a dead world. If a civilization broadcasts for a few centuries and then falls silent, its signals were never strong enough to cross the galaxy in the first place, and whatever did leak out has long since thinned into nothing, indistinguishable from the natural crackle of the cosmos. The radio whisper of a civilization that died 10,000 years ago is not out there waiting to be found. It is gone, smeared into noise, erased by the same distance that makes the galaxy so grand. So the first and most obvious way we might find the dead, by overhearing their old transmissions, turns out to be almost useless. The messages do not survive the journey, and they certainly do not survive the silence that follows. But surely, you might think, the things they built would survive. Cities, machines, monuments. Surely the physical stuff of a civilization sticks around. And here too, the answer is gentler and sadder than we expect, because nothing built lasts without someone to tend it. Everything we make is in a quiet war with time, and the moment the makers are gone, time wins. Metal corrodes, concrete cracks and crumbles, structures fall and are buried. On our own planet, without constant maintenance, our greatest cities would be unrecognizable in a few thousand years, and effectively gone in a few 100,000. Stretch that out to the millions of years we are talking about across cosmic history, and the physical remains of a civilization do not stand as ruins for visitors to find. They return to dust, to ordinary geology, to the slow churn of a living world. And remember the scale of time we are working with. We are not talking about a civilization that died last century. In a galaxy 13 billion years old, the typical dead civilization, if there were many, would have died not thousands but millions, even hundreds of millions of years ago. Across that kind of time, planets resurface themselves. Continents are swallowed and remade. Whole mountain ranges rise and erode to nothing. Against forces like that, what chance does a city have? What chance does any artifact have of being recognizable as artificial after 100 million years of a planet's restless geology grinding it back into the rock? So when we point our telescopes at a distant star and see no flashing lights, no obvious structures, no beacon, we tend to take that as evidence that no one is there and no one ever was. But look at what we have just learned. A civilization could have risen on a world around that very star, flourished for 1,000 years, and died 100 million years ago, and there would be, from our vantage point, absolutely nothing left to see. No signal, because the signals faded within light years and stopped long ago. No ruins, because the ruins crumbled and were buried and recycled into the planet's crust. The absence of evidence we keep treating as an answer may be nothing of the sort. It may be just distance and time, quietly doing what distance and time always do, which is to erase. Let me make this concrete with our own world, because it is the only example we have, and it is a sobering one. Imagine that, tonight, every human being simply vanished, and the earth was left to itself. Within decades, the power would fail, and the lights would go out. Within a century or two, the great buildings would begin to fall, their steel skeletons rusting, their concrete spalling and cracking, as water and frost and root did their patient work. Within a few thousand years, the cities would be mounds and stains. Within 1,000,000 years, a blink in the life of a planet, the surface would be scrubbed nearly clean, our monuments gone, our roads gone, our entire built world folded back into soil and stone. And we are talking, across the galaxy, not about 1,000,000 years, but about tens and hundreds of millions. On those timescales, the question is not whether our ruins would be hard to find. It is whether there would be anything left that could even be called a ruin. Now, turn that around and point it at the sky. When a distant civilization dies, the very same process runs. On its world, around its star, the signals it leaked fade within light years and then stop forever. The structures it raised crumble and are buried and recycled, and all of this happens long before its light has even finished crossing the galaxy to reach us. So by the time we point a telescope at the place where it lived, there is, quite literally, nothing for us to find, no matter how carefully we look. We are not failing to detect the dead because our instruments are weak. We are failing because the dead, in the ordinary course of things, leave nothing to detect. I do not want to overstate it, because honesty is the whole point of this channel, so let me be fair. There are some things a civilization might build that could, in principle, last and be seen. Something truly enormous and durable, like a structure built around an entire star to capture its light, might persist long enough and be large enough to notice, which is exactly why we look for such things. A civilization that wanted to be remembered might deliberately leave a marker meant to outlast the ages. So it is not that the dead are utterly undetectable in every case. It is that the ordinary remains, the signals, and the cities, and the machinery, the things almost any civilization would produce, are precisely the things that vanish fastest. We can only hope to find the dead if they were both enormous and intentional about being found, and most of the dead, like most of the living, were probably neither. So sit with the new shape of the silence. We began tonight thinking the quiet might mean no one is here. Then we saw it might mean no one is here right now, because civilizations are brief sparks that rarely overlap. And now we see something stranger still. Even the ones that did overlap with us, even a civilization burning at this very moment a few thousand light years away, might be completely invisible if it is not actively, deliberately shouting in exactly the way we know to listen for. The galaxy could be full, right now, of the living and the dead alike, and still look to us like an empty room. The silence is not the sound of absence. It might just be the sound of distance. And yet there is a third reason we might find nothing, lonelier than the fading signals and lonelier than the crumbling cities, and it has nothing to do with how far away anyone is. It has to do with when they lived. Because even if the galaxy produced 1,000 civilizations, there is a haunting possibility that we will never meet any of them, not because they are too far, but because we are simply living in the wrong moment. And that idea, the idea of being out of step with everyone who ever was, is where we turn next. Is less than break time equals 1s is greater than number. Part 6. Out of sync. We have been treating the galaxy mostly as a problem of space, of enormous distances between the stars. But there is a second dimension to the loneliness, and in many ways it is the crueler one, because no faster ship and no cleverer telescope can ever solve it. It is the problem of time. Even if the galaxy were home to thousands of civilizations across its history, there is no guarantee that any two of them ever existed at the same moment. The graveyard might be real and full, and yet so spread out across the ages that no two mourners were ever in it together. Think back to the stadium and the matches, but now add the dimension we left out. It is not only that the matches are scattered across an enormous floor, they are also scattered across an enormous span of time. One match was struck and snuffed 1 billion years ago. Another flared 200 million years back. Another might light 1 billion years from now, long after our own has gone cold. To meet another civilization, you do not only need to be close enough in space, you need to overlap in time, to be burning during the same brief window. And when the windows are short and the timeline is 13 billion years long, the overlaps become almost impossibly rare. Let me put real numbers against it so the strangeness lands. Imagine two civilizations, both lasting, say, 10,000 years, which would already make them far longer lived than we have any evidence we will be. Now scatter their starting moments anywhere across 13 billion years of galactic history. The chance that their 10,000-year windows happen to overlap at all is something like 1 in a million. And even if they do overlap, they might be on opposite sides of the galaxy, 100,000 light-years apart, so that a message sent at the dawn of one would not arrive until long after both were dust. Space and time conspire together. To meet, you must clear both hurdles at once, and the universe seems almost designed to make sure you rarely do. There is an image I cannot shake when I think about this, and I want to give it to you. Picture a civilization that arose on a world 50,000 light-years from here, on the far side of the galaxy. Picture that it lived, and wondered, and looked up at its own sky, and maybe asked the very question we are asking tonight, whether it was alone. And picture that it died, 50,000 years ago, gone silent forever. Now here is the thing. The last light of its existence, the final faint radio whisper it ever sent, traveling all this time across all those light years, might be passing through our solar system at this exact moment, washing over the Earth right now as you listen to me. A message, of sorts, arriving precisely on time, and there is no one left at the other end. The sender died while the message was still in transit, 50,000 years before it reached us, and even if we could read it, there would be no one to answer. We would be receiving mail from a house that burned down before the letter was halfway here. There is a particular kind of vertigo in realizing that the night sky you look up at is not a snapshot of the present at all, but a collage of different pasts. The light from a nearby star left it a few years ago. The light from the bright band of the galaxy left it thousands of years ago. When you look across the galaxy, you are not seeing it as it is. You are seeing thousands of separate moments, all arriving at once, none of them now. So if there were a civilization out there, you would never see it as it is. You would only ever see it as it was by the time its light reached you, and by then it could have risen further, or fallen silent, or vanished entirely. The sky is a museum of moments, and every exhibit is older than the last, and some of the lights still shining in it belong to things that no longer exist. We take the constancy of the stars for comfort, but some of that comfort is an illusion. We are looking at a past that may have already ended, lit by fires that may already be cold. That, to me, is the true loneliness of the graveyard. It is not just that the others are far away. It is that the others may be far away in time, which is a distance no ship can ever close. You can build a faster rocket to cross space. You cannot build anything to cross the gap between an era that has ended and an era that has not yet begun. The funerals of the galaxy may have all taken place before our sun even formed. The great age of minds long over, the lights gone out one by one across billions of years, until the night we finally opened our eyes and found the room already dark and still warm. You can run the same cruel arithmetic forward instead of backward, and it does not get any kinder. Suppose, against all the odds, that a civilization arose somewhere close by, only a few hundred light years away, practically next door in galactic terms. Suppose it lasted a respectable few thousand years. For us to have any chance of noticing it, its window of existence would have to overlap with our brief window of being able to listen, which is about 60 years long, and we would have to be pointed in exactly the right direction at exactly the right time. The chance of all of that lining up, even for a neighbor, is faint. Now multiply that faintness across the whole galaxy, across every direction we could look, and every era in which someone could have lived. And the odds of catching anyone at all, in the act of being loud, shrink toward nothing. It is not that the galaxy refuses to hold life. It is that the galaxy is built, in its very dimensions of space and time, to keep its living things from ever sharing a moment. And notice how this ties back to that one number, L, because it always comes back to L. The shorter the lifespan of civilizations, the worse this synchronization problem becomes. If civilizations last only a few centuries, then not only do they flicker alone, almost guaranteed to never share an era with another. A small L does not just thin the crowd in space. It scatters everyone across time so thoroughly that the very concept of meeting becomes almost meaningless. The brevity that makes the matches dim is the same brevity that makes them solitary. Everything we have built tonight, the empty stadium, the invisible ruins, the messages from the dead, all of it flows from the same source, the simple, devastating possibility that minds do not last very long. Let me stack the timelines against each other one final time, so you can feel where we sit. All of recorded human history, every civilization we have ever had, fits into about 5,000 years. The galaxy is 13 billion years old. If you laid the whole history of the galaxy along a single year, all of human civilization, from the first cities to this very sentence, would occupy the final 10 seconds before midnight on the last day. We are not just latecomers. We are a flicker so brief that if there were others, the odds that any of them are flickering during our particular 10 seconds are achingly small. We may genuinely be the only light currently lit in this entire corner of the dark, surrounded by the cold remains of all the lights that came before. So, let us gather what we have built, because Act 2 is closing and the picture is now complete. We expected a crowded galaxy, full of company. Instead, we found a silence. And we have now seen 3 reasons that silence could hide a graveyard rather than an empty room. The civilizations are brief sparks that rarely burn at once. Their remains are invisible to us across distance and time, faded and crumbled and erased. And even the few that might overlap with us are scattered so far across the ages that we are almost certainly living out of sync with everyone who ever was. Put those 3 together, and you have a galaxy that could be utterly full of the dead and yet appear, to our instruments, perfectly empty. But I told you at the start that this idea, the graveyard, is not just sad. It is frightening, genuinely frightening, in a way that an empty galaxy would not be. And I have been holding back the reason all night. Because if the galaxy really is full of the dead, then we have to ask the question that follows, the one that turns this from a melancholy thought into something that should make us sit up in the dark. What killed them? And more to the point, whatever it was, is it still out there, waiting, somewhere up ahead of us, on the same road we are walking right now, is less than break time, equals 1s, is greater than, number, part 7, the filter, behind or ahead. In 1996, an economist and thinker named Robin Hanson took the great silence and turned it into one of the most quietly terrifying ideas in all of science. He did not set out to frighten anyone. He set out to be logical, and the logic led somewhere cold. He called his idea the Great Filter, and once you understand it, you cannot look at the silence the same way again, because it tells you why a galaxy full of the dead would be the worst possible thing we could ever find. Here is the reasoning, and it is worth following slowly. We have a path, a long ladder, that runs from the simplest possible beginning all the way up to a galaxy-spanning civilization. At the bottom rung is lifeless chemistry, just the right molecules on the right world. Above that is the first living cell. Above that, complex life. Then intelligence. Then technology. Then a civilization that spreads beyond its home world and endures for ages, becoming the kind of presence that fills a galaxy and never goes silent. That is the top of the ladder. And the brutal fact is this. We look out at the galaxy and we see no one at the top. So something, somewhere on that ladder, must be stopping almost everyone from climbing all the way up. Hansen called that something the Great Filter. At least one rung on the ladder must be so difficult, so improbable, that almost nothing that starts the climb ever finishes it. Now comes the part that matters, the question that should keep you up at night. Where on the ladder is the filter? And there are really only 2 possibilities. Either the filter is behind us, on a rung we have already climbed past, or it is ahead of us, on a rung we have not yet reached. Those 2 options sound similar. They are anything but. They are the difference between hope and dread. Suppose the filter is behind us. Suppose the nearly impossible step, the one that stops almost everyone, was something like the leap from dead chemistry to the first living thing, or the leap from simple cells to complex ones, or the emergence of intelligence itself. If that is true, then the reason the galaxy is silent is simply that almost nothing ever makes it as far as we have. We are the freak accident, the one in a trillion roll that came up right. The galaxy is quiet because it is nearly empty, because the ladder is almost impossible to climb, and we, against staggering odds, already climbed the hardest part. In that story, the future is wide open. The worst is behind us. We are rare and lonely and free. But now suppose the filter is ahead of us. Suppose all those earlier rungs are actually fairly easy, that life starts readily, that intelligence is common, that civilizations arise all the time. In that story, the galaxy was indeed once full of climbers, exactly the graveyard we have been building all night. But there is some rung still above us, some step between where we are now and the long, enduring future we imagine, that almost no one survives. A filter that lies in our future. And if that is the truth, then all those dead civilizations are not a curiosity. They are a warning. They are a long line of climbers who got exactly as far as we have, who built their radios and looked up at their silent skies and felt clever and alone, and then hit the same wall that is waiting for us and fell. What makes this so hard to sit with is that we cannot currently tell which of the two stories we are in, and the same evidence fits both. The silence is consistent with a filter behind us, a galaxy that is nearly empty because almost nothing ever climbs this high. And the silence is equally consistent with a filter ahead of us, a galaxy that was once full and emptied out before anyone could endure. The data we have, which is the absence of data, does not distinguish them. The only thing that would tip the balance is finding something. And this is the cruel twist, because what we find determines which story is true. Find that life is everywhere, that simple living worlds are common, and you have shifted the filter forward, toward us, because it means the early steps were easy, and the hard step must come later. Find that life is nowhere, that we are a true fluke, and you can breathe easier, because it means the hard step is already behind us. We are in the strange position where good news and bad news are inverted from what intuition expects. This is the chilling corollary, and I want to state it as plainly as I can, because it inverts everything your instincts tell you. The more dead civilizations there are out there, the worse our own odds become. If we ever found the ruins of an alien civilization, if we ever discovered the bones of a culture that rose and fell, most people would call it the greatest discovery in history. Hansen's logic says it might be the worst news we ever received. Because every dead civilization we find is proof that the filter is not behind us, that reaching our stage is not the hard part, that the wall comes later, after the radios and the telescopes and the long, silent wandering, and that we are walking toward it right now without knowing what it is. It means that, strange as it sounds, the silence might be the good news. An empty sky, a galaxy, where we truly are among the first and the rare, would mean the hardest step is behind us. But a graveyard, a galaxy littered with the dead, would mean the hardest step is still to come, and that countless others, no doubt feeling as clever and capable as we feel tonight, walked straight into it. And that brings us right back to the number we cannot escape, because a filter ahead of us is not some abstract idea. It is precisely the thing that makes L small. It is the mechanism, whatever it turns out to be, that cuts every civilization short at roughly our stage and turns the galaxy into the field of brief sparks we built in Act 2. The Great Filter and the Small Lifespan are two names for the same shadow. So the only question left is the one no one wants to ask out loud. If there is a wall ahead, what is it made of? Is less than break time equals 1s is greater than number, part 8, the ways a world ends. If there really is a filter waiting for us, a wall that almost no civilization survives, then we ought to be able to guess at what it might be, because we can look at our own situation and ask which of our challenges might be the kind that no one ever quite gets past. I want to walk through these calmly, not to alarm you, but because understanding the shape of the danger is the only thing that has ever helped anyone avoid it. And there is a thread that runs through all of them, a single, grim irony that ties them to everything we have said. The most familiar candidate is self-destruction, and it has an ironic structure that is worth seeing clearly. The very technologies that make a civilization powerful enough to be noticed across space are the same technologies that give it the power to end itself. We learned to split the atom, and almost in the same breath, we built enough weapons to unmake our own world several times over. The knowledge that lets you light a beacon for the galaxy is the same knowledge that lets you put out your own light. Carl Sagan worried about exactly this decades ago. He suspected that the window between when a civilization becomes detectable and when it gains the power to destroy itself might be very short, and that many civilizations might not survive their own adolescence, that dangerous stretch when your power has outrun your wisdom. If that is the common story, then L is small precisely because growing loud and growing dangerous happen at the same moment. Beyond the bombs, there are quieter ways a world might end. A civilization might alter the chemistry of its own planet's air and water faster than it can adapt, changing the climate of its only home until that home turns against it. It might engineer something biological, a tool meant to heal that becomes a plague it cannot stop. It might exhaust the resources it depends on, building a complexity it can no longer feed. None of these require any villain or any catastrophe from outside. They are all just the ordinary consequences of a civilization growing more powerful faster than it grows more careful, and any one of them, repeated across the galaxy, would leave behind exactly the kind of brief, silent, vanished cultures we have been imagining. There is also the worry that gets the most attention lately, the possibility of creating a form of intelligence we can no longer control, a technology that slips out of our hands and follows goals of its own. I will not dwell on it, because the truth is, we genuinely do not know whether that is a real filter or a passing fear, and this channel does not trade in panic. I only mention it because it fits the pattern. It is, once again, a danger that arrives precisely at the stage of technological power, the stage we are entering now, the stage right around where every dead civilization in our graveyard would have fallen silent. But not every ending is loud, and here is where the newest thinking gets genuinely surprising, because it suggests a filter that looks nothing like a catastrophe at all. Some researchers have recently proposed that civilizations might simply fade. The idea goes like this. As a species climbs to the top of its world, conquers its predators, masters its diseases, and grows comfortable, the old pressures that drove it to multiply relax. With comfort and knowledge come the means to choose smaller families, and over many generations a civilization might quietly shrink, generation by generation, not through any disaster, but through a slow, gentle decline in numbers until it simply dwindles away. It is a surprising thought, and I want to flag clearly that this is a recent and speculative idea, not an established fact. But it paints a haunting picture, not a bang, not even a whimper, just a long, soft quieting, a civilization growing old and few, and finally still, the lights going out not in fire, but in something more like sleep. There is something worth noticing about the rhythm of all these dangers, which is that they tend to cluster together at the same stage, and it happens to be our stage. A civilization does not gain the power to split the atom, rewrite the code of life, change the climate of its world, and build minds out of metal at 4 separate moments spread across millions of years. It gains all of these powers in a sudden rush, within a century or two of one another, in the same brief window when it first becomes loud enough to notice from space. That clustering is exactly what you would expect if there is a filter, because it means the most dangerous moment in a civilization's life arrives all at once, like a series of doors opening in the same hallway, each one leading to a different way of falling. We are standing in that hallway right now. We opened the first door less than a century ago, and we genuinely do not know how many more doors are ahead of us, or how many other civilizations stepped into this same hallway, full of confidence and never stepped out. And that, in a way, is the unifying point that ties this whole act together. Most of the ways a world ends do not end in an explosion we could see from light years away. They end in a slow quiet, a fading, a falling still, which is exactly why the graveyard would be silent. We keep imagining that if civilizations died, we would somehow see the wreckage, the great cosmic catastrophe. But the truth is that most endings, whether by self-destruction or exhaustion or simple decline, leave behind nothing but quiet. Every one of these stories is really the same story told in different ways. Each one is a description of how L gets cut short. Each is a different way the match burns out, leaving behind one more dark and silent spark in the enormous graveyard we have been walking through all night. The filter, whatever it is, does not roar. It hushes. And so far, every world it has hushed has stayed hushed. So we have followed the graveyard idea about as far into the dark as it goes. But I have been keeping a promise in my back pocket this whole time. I told you the dead might not be as far away as the stars. I told you this idea could be made personal, brought down out of the abstract sky, and placed somewhere you can actually stand. Because there is a question that takes everything we have just discussed and asks it not about some distant world, but about the ground beneath your own feet. Could a civilization have risen and fallen right here, on Earth, long before us, and left almost no trace at all? And the answer is far less comfortable than you would hope. Is less than break time equals 1s, is greater, number part 9, the graveyard at home. In 2018, two scientists, a climate physicist named Gavin Schmidt and an astronomer named Adam Frank, sat down to ask a question so strange that they gave it a slightly tongue-in-cheek name, borrowed from an old science fiction television show. They called it the Silurian hypothesis. And I want to be very clear about what they were and were not saying, because it is easy to misunderstand, and the misunderstanding is far less interesting than the truth. They were not claiming that an ancient civilization existed on Earth before us. They were asking something far more careful and, in a way, far more unsettling. If one had, would we even be able to tell? It is worth pausing on why a serious astronomer would ask such a thing. Adam Frank studies the possibility of life on other worlds, and he realized that there was a hole in his own reasoning. When we go looking for the traces of dead civilizations on distant planets, we make assumptions about what those traces would look like and how long they would last. But we had never really tested those assumptions, and the only laboratory we have, the only planet whose history we can read in any detail, is our own. So Earth became the test case. Not because anyone thought there were dinosaurs with radios, but because Earth is the one place where we can actually check how thoroughly time erases the evidence of the past. The question about aliens turned, quietly, into a question about us. So consider the problem honestly. Our own industrial civilization, the one that has reshaped the surface of this planet, is only a few hundred years old. Before that, for hundreds of millions of years, there were complex creatures, enormous animals, entire ages of life that came and went. The dinosaurs alone ruled this world for well over 150 million years, a span that makes our few thousand years of recorded history look like nothing at all. Now ask yourself a simple, jarring question. How much do we actually know about any single century of the dinosaur age? Could we point to a particular 10,000-year window, 60 or 100 million years ago, and say with confidence what happened in it? The honest answer is no. The resolution of the geological record that far back is terrible. Entire spans of time that would dwarf all of human history are compressed into thin layers of rock, or missing altogether. And that is the crux of the whole thing. If a civilization had arisen 60 million years ago and lasted, say, a few thousand years, or even a few tens of thousands, the same length of time as ours, would it leave a mark thick enough to survive in that smeared and broken record? Schmidt and Frank worked through it carefully, and the conclusion is genuinely sobering. almost everything we think of as the evidence of our existence would be gone. Our cities, every one of them, would be ground to nothing. The continents themselves are recycled over such timescales, dragged down and remade, and even the parts that survive are eroded layer by layer. The buildings, the roads, the monuments we imagine lasting forever, none of it would register as anything but a faint smear, if it registered at all. A future geologist, or a visiting alien, digging through the rock of our era 100 million years from now, would find no skyscrapers, no machines, no statues. They would find, at most, a strange chemical whisper. Because here is the subtle part, the part that turns this from a sad story into a real scientific puzzle. While the physical objects vanish, certain chemical signatures might just barely persist. The act of running an industrial civilization changes the planet in ways that get written into the chemistry of the rock and the ice. The particular balance of carbon left behind by burning enormous amounts of ancient fuel, unusual traces of certain metals, strange synthetic molecules, the kind nature does not make on its own. Sudden shifts in the planet's temperature and the composition of its air, recorded in the layers. These are faint, ambiguous fingerprints, the kind you would only notice if you already suspected they might be there. And the strangest realization of all is this. When geologists look back at the ancient past, they do sometimes find sudden, mysterious chemical events, brief spikes of warming or odd shifts in the carbon record that they currently explain through entirely natural causes. The Silurian hypothesis does not claim those were civilizations. It simply points out, with uncomfortable honesty, that if one had existed, its signature might look an awful lot like the kinds of anomalies we already see and shrug off. It is worth naming the particular fingerprints we ourselves are leaving, because they are the clearest guide to what we might look for in the ancient past, here or anywhere. We have scattered synthetic molecules across the planet that nature never made, long-lived plastics that break into smaller and smaller fragments and work their way into the rock. We have doubled the amount of certain reactive forms of nitrogen in the soil and water by manufacturing fertilizer on an industrial scale. We have spread a thin, unmistakable layer of radioactive elements around the entire globe, from the testing of nuclear weapons, isotopes that simply did not exist in those proportions before. We have shifted the balance of carbon in the air by burning fuels laid down hundreds of millions of years ago, leaving a chemical signature in the very composition of the atmosphere. Most of these specific traces will themselves fade over millions of years, but the subtler shadows they cast, the sudden warming, the strange spike in certain elements, the abrupt change in the carbon record, those might just survive as a faint smudge in the rock. And that smudge is precisely the kind of thing a future investigator would have to decide how to read. I want to dwell on what this does to the graveyard idea, because it changes it from something cosmic and abstract into something that should give you a small chill standing in your own kitchen. We have spent this whole night talking about dead civilizations as a thing that might fill the distant galaxy, thousands of light years away, a melancholy abstraction. But the Silurian hypothesis brings it home, all the way home, to the actual rock beneath your feet. It says that the erasure we have been describing, the way time grinds civilizations into invisibility, is not some exotic property of faraway worlds. It is happening here. It is happening to us. The very ground you are standing on has been remade many times over and could be hiding, in principle, the chemical ghost of something that lived and thought and died long before the first human ever drew breath. And let me be careful and fair, because the truth matters more than the chill. There is no evidence that such a civilization existed. None. The most likely reading of Earth's history, by far, is that we are the first and only technological civilization this planet has produced. The ancient chemical anomalies we find almost certainly do have natural explanations, and scientists have good reasons for those explanations. The Silurian hypothesis is a thought experiment, not a discovery, and Schmidt and Frank were the first to insist on that. But the value of the thought experiment is not in claiming that the past was full of forgotten cities. Its value is in what it proves about our ability to know. It proves that absence of evidence, on the scale of millions of years, is almost worthless as proof of absence. It proves that a civilization can be erased so completely that even standing on top of where it lived, digging through its very bones, we might not be able to tell it was ever there. Now take that proof and lift it back up to the stars, because this is where it pays off. If our own planet, the one world we can examine in detail, the one place where we can dig and measure and test, could hide a lost civilization so thoroughly that we could not be sure either way, then think about what that means for the billions of worlds we cannot examine at all, worlds we can only see as faint points of light if we can see them as anything. If the evidence can vanish this completely right here, under our feet, where we are actively looking, then across the galaxy it would vanish 1,000 times more completely. The Silurian hypothesis is the graveyard thesis in miniature, a working model of the whole idea, scaled down to a single planet we can actually study. And what it shows is that the silence, even of a world that was once full of life, and possibly minds, is exactly what we should expect to find. Not because the world was empty, but because the same patient erosion that hides the past here would hide it everywhere. Let me try to make the timescale itself something you can feel, because numbers like 100 million years slide right off the mind. Picture the entire history of complex life on Earth, going back about 500 million years, laid out as the length of a single football field, 100 yards from end to end. On that field, all of recorded human history, every pharaoh and every empire and every word ever written down would occupy a strip thinner than a single blade of grass at the very last inch. Our industrial age, the few centuries in which we have built anything that might leave a chemical trace, would be a smear too small to see without a microscope. Now ask yourself, if there were another such smear somewhere earlier on that field, 60 yards back, 80 yards back, would you find it? Could you even see it against 100 yards of churning, eroding, recycling rock? You would walk right over it and never know. I find that there is something almost tender in this, underneath the unease. The Silurian hypothesis is, in the end, a meditation on how completely the world forgets. Everything that any creature has ever built, every structure raised against the dark, is in a slow conversation with time, and time always has the last word. It is not cruel. It is just patient. And the same patience that would erase a forgotten civilization beneath our feet is the patience that has, perhaps, already erased 1 million civilizations across the galaxy, leaving behind a silence we mistake for emptiness. When we look up and see nothing, we are not seeing proof that nothing was ever there. We are seeing the ordinary work of time, the same work going on in the rock below us, finished long ago on 1,000 other worlds. So the graveyard is not only out there, scattered among the distant stars, it is a principle, a law almost, written into how reality treats the past, and it operates as surely on Earth as it does at the far edge of the galaxy. That is the unsettling gift of the Silurian hypothesis. It takes the grandest cosmic mystery and shows you that its logic is sitting quietly under your own shoes. The galactic graveyard looks, from here, exactly like an empty room, for the very same reason that our own planet's distant past looks, from here, like a blank page. The writing was there. Time simply rubbed it out. But I promised you, at the very beginning of tonight, that this story does not only travel into the dark. I told you there was a light left on in a far room, a reversal waiting for us. We have followed the graveyard about as far as it goes, through the brief sparks and the invisible ruins and the wall that may lie ahead and the forgetting written into the rock. Now it is time to turn around and give the other answers their due and ask whether the silence might mean something other than death after all. Because not everyone believes the galaxy is a graveyard. Some think the quiet is a choice. And one beautiful idea suggests the dead are not dead at all, is less than break time equals 1s, is greater than number, part 10. The silence might be chosen. There is a reading of the silence that has nothing to do with death, and it is one of the more chilling alternatives in its own way. It was made famous by the novelist Liu Cixin, though its roots run older, and it is usually called the dark forest. The idea is that the galaxy is not quiet because everyone died. It is quiet because everyone is hiding, on purpose, and for very good reason. Picture the galaxy as a forest at night, full of hunters, and imagine that you cannot tell from a stranger's silhouette whether they are friendly or deadly, and you cannot afford to guess wrong, because guessing wrong could mean annihilation. In that forest, the only safe move is to stay perfectly silent and to assume that anyone foolish enough to call out loud will be the first to be silenced. In this telling, the civilizations that died were precisely the ones that broke the quiet, and the survivors are the ones who learned to say nothing at all. I should flag clearly that this idea comes more from fiction and philosophy than from mainstream science, but it is taken seriously as a possibility, and it sharpens our graveyard rather than replacing it. It suggests the dead are real, but that they were hunted, not merely unlucky, and that the silence is being kept on purpose by whoever is left. There is a kinder alternative too, one that imagines the others are alive and well and simply leaving us alone. It is sometimes called the zoo hypothesis, the idea that a galaxy of advanced civilizations might have agreed, the way we set aside a nature preserve, to watch developing worlds, like ours, from a respectful distance without interfering, letting us grow up on our own. In that version, the silence is not death and not fear, but courtesy, a deliberate hush maintained so that we can find our own way. I mention it not because there is any evidence for it, there is none, but because it shows how many different stories the same silence can hold. The quiet sky is a kind of mirror. People who fear annihilation see a dark forest in it. People who hope see gentle guardians. And people who have followed the numbers, as we have tonight, see a graveyard. The data does not yet force any of these on us, which is exactly why we have to be so careful not to fall in love with the one that suits our mood. There is a gentler caution to draw here too, and it is about us, not them. We are so hungry to find the dead, so primed to read meaning into the dark, that we keep mistaking ordinary noise for ruins. A few years ago, there was tremendous excitement about a star, often called Tabby's star, that dimmed in strange, irregular ways that no one could immediately explain. Some wondered, out loud and seriously, whether we were watching the shadow of an enormous alien structure passing in front of it. It was a thrilling thought. It was also, almost certainly, wrong. The best evidence now points to nothing more exotic than uneven clouds of dust. The same thing happened with a strange visitor from another star system, an elongated object that tumbled through our solar system on an odd path, which a few voices suggested might be a piece of alien technology. Most scientists think it was a natural fragment, peculiar but not built. These episodes are worth remembering because they show how badly we want to find the others, living or dead. We see ruins in the static. We hear footsteps in an empty house. And that hunger should make us humble about how thin the real evidence actually is. And then there is the possibility that turns the entire graveyard inside out, the one that says we have the timing exactly backwards. We have spent all night assuming we arrived late, that the great age of civilizations is behind us. But some thinkers, working from careful models of when life is most likely to arise across the long future of the universe, argue the opposite. They argue that the universe will keep making stars and worlds for trillions of years, which means the era of civilizations may be just beginning, and that we, far from being latecomers stumbling into a graveyard, might be among the very first guests to arrive, sitting in an empty hall because the party has not started yet. In that reading, the galaxy is not full of the dead. It is full of the not yet born, of all the minds that will arise long after our own sun has burned out. And notice how each of these alternatives, the chosen silence, the misread noise, the early arrival, is really just a different guess about that same number and that same timing we have circled all night. They change why the sky is quiet. They do not let any of us off the hook of not knowing how long anyone lasts, or whether we are near the beginning of the story or somewhere lonely in its middle. The silence still belongs to L. Is less than break time equals 1s, is greater than number, part 11. Or they're only sleeping. I have saved the gentlest reversal for last, because it is the one that suits the late hour, and because it does the loveliest thing an idea can do. It takes the image we have been afraid of all night, the graveyard, and asks whether we have been misreading it entirely. In 2017, a group of researchers proposed something they called the aestivation hypothesis, and the word aestivation means to sleep through the heat, the way some animals go dormant through a hot, dry season and wake when the world cools. Their idea is strange and beautiful and, I should say clearly, entirely speculative, though it was put forward seriously by serious people. They suggested that the most advanced civilizations might not be dead at all. They might simply be asleep. The reasoning runs on a quiet piece of physics. It turns out that the universe right now is, in a certain sense, too warm for the most efficient possible thinking. Every act of computation, every thought a machine might have, costs a little energy and throws off a little waste heat, and the colder the surroundings, the less it costs. The universe is slowly cooling as it expands, and it will go on cooling for an almost unimaginable stretch of time. So a civilization that had become patient beyond our understanding, and that cared above all about how much thinking it could ultimately do, might choose to do something astonishing. It might gather its resources, build its great sleeping engines, and simply wait, dormant, for the universe to grow cold enough that its thoughts would run vastly more efficiently. It would sleep through the warm early ages of the cosmos, ages that include right now, and set itself to wake in a far colder, far older universe we will never live to see. If that were true, then everything we have called a graveyard tonight would be something else entirely. The silence would not be the quiet of the dead. It would be the quiet of the sleeping. The dark worlds we imagined as ruins would be more like still figures under blankets, breathing slowly, waiting for an alarm set to ring, in an age so far ahead that the stars themselves will have changed. We would be not the last guests in an empty hall, but the only ones awake in a house full of sleepers, tiptoeing through the dark, mistaking their stillness for absence. It is, I think, the most hopeful version of the silence anyone has offered, and it costs us nothing to hold it beside the darker ones, because the truth is, we do not know which is right. And that is where we have to leave it, with the honesty this whole night has been built on. We do not know whether the galaxy is a graveyard, an empty stage waiting for its first players, a forest of hunters holding their breath, or a dormitory of sleepers set to wake in the cold. We do not know, because in the end, it all comes back to the one number we have circled since the first minute, the lifespan of a civilization, the value of L, and we have exactly one example to learn it from, and that example is us, and our story is not finished. We are the single match recently struck that cannot yet see whether it will gutter out or become a fire that lasts an age. So here is the thought I want to leave you with. As the lights go down, the question we started with, whether our galaxy is full of dead civilizations, turns out to be a question about the past. But the only part of the answer we can actually touch lies in the future, and it is ours to write. Every dead civilization that may be out there, if there are any, already chose its value of L, already lived its length, and fell silent. The one length still unwritten, the one match whose burning is still in our hands, is our own. Whatever the galaxy was, whatever silence it keeps, the only voice we can decide the fate of is this one, on this small blue world, on this ordinary night, and maybe that is the real reason the question matters. Not because of what it tells us about the dead, but because of what it asks of the living. So settle in, stay warm, and as you drift off tonight, let yourself wonder, gently, what kind of light we are going to be, and how long we mean to keep it burning.